Hello student, today we are going to discuss about CBSE sample paper. It is a 22-23 question paper. We are going to discuss especially physics solution we are going to do. First we will see the question paper pattern. It is called general instruction. Totally it is 80 marks exam and it is going to be a 3 hours. Subject code is 086. Science paper physics solution alone we are going to see. Before going to the question paper, we will discuss what is the question paper pattern. Okay. So, actually section A, B, C, D, E. There are 5 sections. Okay. Section A is for the 1 mark. Okay. 21 mark. So, we will have 20 marks. Okay. The next section B is a 2 mark, 6 2 mark. So, we will have 12 mark. Section C is a 3 mark, 7 3 marks, we can have it is 21 marks. Section D is it is 5 mark, 3 5 mark, we can get 15 marks. Section E is a case study question, so 4 into 1, each subject is a 4 mark, it's a kind of MCQ only. So it is a 4, 4, 4. So physics, chemistry, bio, each one will get us a one case study question, so it is 12 marks. So totally we'll get as a 80 marks as a science question paper. Okay. Now we'll see one by one question. Okay. Now physics question alone we are going to do. Question number 13. Okay. It is physics question. What is the question as asked now? If it is a wire, copper wire, the current is flowing inside the wire. If temperature is increased, what will be happen about the resistance? Okay, if temperature increases, no, resistance will increase. Already we know one of the factors. Okay, temperature and resistance directly proportional. If temperature increase, resistance will increase. So the resistance going to increase. Okay, so 13th question, the answer we can call as option C. Okay, the resistance will increase because it's directly proportional. Okay, then question number 14, this is a diagram is given. Okay, so this diagram, no, you have to use with the Fleming left hand rule. Okay, so Fleming left hand rule, FBI. Okay, so it is a 14th question, physics question. So force, magnetic field and current. Okay, so they asked which two direction we are going to use when the current is flowing this way, magnetic field is this way. Okay, I used Fleming left hand rule. The force we are getting as upwards, that's called towards north side. Okay, in case the north and south is changed, like this, opposite way. Okay, so what we'll get now, magnetic field this way is going, magnetic field will be changing opposite sides, still the force will get as so now when the magnetic field is changing, the force will create downwards. Same way they are asking about the current is changing the direction, forces will get as a downwards. Okay, the conclusion, whether magnetic field is reversed, okay, the force will get opposite direction. Before it was north, now it will be south. Okay, the force will get changed. Even current is reversed, the force will get reversed. Okay, the point we are going to use up and down, that's called north and south alone we are going to use. North and south alone we are going to use. Okay, so the answer for this question is how many direction out of 4 direction, how many direction is going to act with when we are changing with the current and magnetic field? There are 2 direction will be changing. Okay, up and down, that's called north and south will be act. I used right and thumb rule to find. Okay, it is like understanding question and 3D view you should imagine, then only you will get the answer. Okay, then question number 15. Okay, they asked it is a conductor. Okay, diameter D, length L conductor. Okay, so they asked, they want to decrease the resistance. Question number 15, the resistance they want to decrease. Diameter, what we have to do with the diameter? Okay, so I want to decrease the resistance. Okay, so what I can do now? By increasing dash, by increasing dia, because resistance inversely proportional to the area, that's called inversely proportional to pi r square. It is called area we can call as a pi r square. For circular area, pi r square. Radius is equal to dia divided by 2. So resistance inversely proportional to pi d square divided by 2, that's called d by 2 whole square, okay, because resistance is d by 2. So resistance inversely proportional to pi d square divided by 4, denominator directly will go in numerator, directly proportional to 4 by pi d square. Resistance inversely proportional to diameter square. Okay, I want to decrease the resistance, you can increase the dia. Actually question is asked about if you want to decrease the resistance, what we have to increase? Actually we have to increase with the diameter of the wire. Diameter of the wire. Okay, what about another two answer? Okay, what about another two answer? No, example, we'll take it as a length. Resistance directly proportional to length. If you increase length, resistance will increase, so that is wrong answer. A wrong answer. Temperature directly proportional to resistance. If you increase temperature, resistance will increase, this also wrong. Okay, and thickness of the insulated pipe. Okay, insulated pipe, it's only depend on the conductor, is not going to depend. So the diameter is inversely proportional to the squaring, the resistance inversely proportional to the squaring of diameter. It is a correct answer. If you increase dia, resistance will get decreased. This answer also we completed. Option B is a correct answer. Okay, the next one, when the straight wire, question number 16, when the straight wire current is flowing, how the magnetic field will be? So circular magnetic field will be there. I used right hand thumb rule to find the magnetic field direction. Okay, so magnetic field will be like this. Okay, right hand thumb rule is used for find magnetic field. Fleming left hand rule, it is used to find it is a force direction. Fleming right hand rule, it is used for induced current direction. Okay, here magnetic field is a circular magnetic field will be produced. It's a concentric, it's like a circle magnetic field will be there. So concentric circle around the wire, it is a correct answer. Okay, now we'll go with the reasoning assertion question. Okay, the question basically asked about the solenoid coil. Question number 20. Okay, so they are given A, B, C, D. It's like a choose the correct answer only. We have to choose with correct answer. Okay, sometime A and B can be true, and R is a correct explanation of A also sometime will be there. They are given us some lot of combination. A and B are true, but it's not related. A is not related with R, the second option. A is true, R is false, A is false, R is true. Like that will be combination will be there. A is assertion, R is reasoning. Okay, we'll discuss only physics question. On the freely suspended solenoid coil, when it comes to the rest. Okay, so freely suspended solenoid coil, when it is suspended with the suspended freely, what will be happen? Solenoid coil behave like a bar magnet. Okay, it will show north and south direction. It is correct. So why it is happening? Because solenoid coil behave like a bar magnet. Okay, so they are telling it's geometrically north and south, it will come correct. So bar magnet will be pointing north and south direction. Now we'll see the reasoning. Because one end of the solenoid coil behave a north pole, another end will be south pole. It is a correct explanation. Both are true, and reasoning is a correct explanation of assertion. Okay, that means A option is the correct answer. Now we'll see other question also. We'll see the answer without explanation. For first question, option C. Okay, second question, it's a choose the correct answer, option B. Question number 3, option C will be there. Okay, question number 4, option B, chemistry question. Okay, question number 5, it's going to be option D.